So integration again, this time integration combined with partial fractions. So we've got to express this thing in this given form, which is effectively partial fraction form. And the first thing I'm going to do is to factorize the denominator, which unsurprisingly is the multiple of these two things here. So I want to express this now in this form, so it's going to be identically equal to that. So now I've got this identity, I'm going to multiply everything by that denominator there. And when I do that, all of ax plus b is going to be multiplied by that denominator. But when I take c over 2x minus 1 and multiply it by 2x minus 1 times x plus 2, then the 2x minus 1's cancel, and I'm going to be left with c times x plus 2. When I multiply the d over x plus 2 by 2x minus 1 times x plus 2, the x plus 2 factors are going to cancel, and I'm going to be left with d times 2x minus 1. So that's what it all looks like when I've multiplied by the denominator 2x minus 1 times x plus 2. And this is an identity, and it's important to understand that because it's an identity, I can then do two things. I can compare coefficients on each side of the identity, the x cubed, the x squared, the x, and the independent terms, and I can also substitute any value for x that I wish. And I can combine these things together. I can mix and match them to make my life as easy as possible. So the first thing I'm going to do is substitute the value x a equals minus 2, because that will make that equal to 0 and that equal to 0. So when I put x equals minus 2 into this expression, I get minus 2 cubed plus 3, which is minus 5. This becomes 0, this becomes 0, and then that's minus 5d. So that's what happens, and that gives me d equals 1. So the next easiest thing I can do is to substitute x equal a half, because when I do that, this will become 0 and that will become 0. So when I put x equals a half into everywhere in this identity, I get that, which gives me the value of c. So I'm making some good progress here, but I've run out of very easy values of x, so I'm going to switch to my alternate tactic, which is to compare coefficients. Comparing coefficients of x cubed, well, on the left hand side I've just got one lot of x cubed, and on the right hand side the only way I can get x cubed is by multiplying 2x by x by ax. So that would give me 2a x cubed. So comparing coefficients of x cubed, I get 1 equals 2a. So the value of a comes out very smartly, very easily. Okay, so I've got a range of different possibilities that I might use to find d. For me, the one I've chosen is to use another value of x equals 0, substitute that in everywhere, and then that becomes 0, so I'm left with 3 here, and then this is minus 1, 2, and then b, so that would be minus 2b. This is 2c, which is 5 over 2, and this would become minus d, which is minus 1. So when I put all of that in, I get that little formula there, or equation rather, and from that I can work out the value of b as minus 3/4. So I found all the values of the variables a, b, c and d, the values to be found, and I can then answer the question, because the question is to express f of x in this form. The question isn't just to find the values of a, b, c and d, it is to express f of x in that form. So it's not until you write that down that you get that mark. So the second part is to find the integral of f of x. So the integral of f of x, we're going to use the first part of the question now to split f of x into its smaller parts. So the integral of a half x is something that should be fairly straightforward to you, and minus 3/4, integrating that should be familiar to you. The integral of 1 over x plus 2, that's just ln x plus 2. So what about this one here? This is a little bit more complex, but what I'm going to do is I'm going to say that the integral of 5 over 4 2x minus 1 dx, we can take a multiplicative constant outside of the integral. So this is 5 over 4 times the integral of 1 over 2x minus 1. Okay, so this is looking a little bit easier. It's 5 over 4. Now, this looks like the integral of that might be ln of 2x minus 1. But remember that when we differentiate ln 2x minus 1, we're going to get a 2 on the denominator, not a 1. So that means we have to multiply by a half. So then this 5 over 4 times a half becomes 5/8. So there we are. Half x squared the half x integrates to a quarter x squared. Minus 3/4 goes to minus 3/4 x. 5 over 4 2x minus 1, that's what we just did. And then ln x plus 2, not forgetting the plus c. So there we are. Hope you managed to do most of that, or if not, then follow what I've just done.